In our last lesson, we talked about the definition of bases based on Arrhenius' definition and Bronsted-Lowry, where we said, according to Arrhenius, a base is simply a substance which, when dissolved in water, ionizes to give hydroxyl ion as the only negatively charged ion. Similarly, according to Bronsted-Lowry, a base is a proton acceptor. And out of that, we were able to tell that ammonia is a Bronsted-Lowry base. You know, when we were talking about Form 3 chemistry, we said that ammonia is able to turn moist red litmus paper blue, showing its basic property. So it is this topic that now categorizes for us well how ammonia is treated as a base. Because it is this topic that tells that ammonia is a proton acceptor, which, according to Bronsted-Lowry, becomes a base. Therefore, ammonia gas is fully basic in nature. In this lesson today, let us now discuss the strength of these bases. Which ones are stronger than the other? So that is, a strong base is one which dissociates completely completely in water, to produce many hydroxide ion. And a good example is potassium hydroxide, which ionizes to give potassium ion and hydroxyl ion, the so-called hydroxide ion. Another one is sodium ion and that ionizes to give sodium ion and hydroxide ion, completely to give the hydroxide ion. Weak bases dissociate in water to produce few hydrogen ions, and they dissociate to give indeed few hydroxyl ion. Dissociate in water to give few hydroxyl ions. A good example is ammonia solution, which dissociates to give ammonium ion and hydroxyl ion. So this is known as a weak base. Just like we talked about the strength of the acids, we are able to use the same to tell which base is stronger than the other and why. And we want to start that by looking at the behavior when we use universal indicator. So the first one is a universal indicator. So with the universal indicator, strong bases have higher pH values. They have higher pH values, and that is between 10 to 14. Reason being that they have many hydroxyl ion and few hydrogen ions. Remember, pH is about potential hydrogen. So when the number of hydrogen ions are very few, then the pH value goes higher. So they have many hydroxyl ion, and that is why their pH values is high. So the higher the number of hydroxide ions, the higher the pH value, and that is why sodium hydroxide, which is a strong base, has a pH value above 10. Weak bases have slightly lower pH values, that is between 7 to 10. For these ones, they have fewer hydroxide ions compared to the strong bases, and that is why their pH values are lower, and that is between 7 and 10. So if we consider the examples we have mentioned, that is ammonia and sodium hydroxide, then sodium hydroxide has a higher pH value, and then ammonia solution has a lower pH value because it has fewer hydroxide ion compared to sodium hydroxide solution. Another reasoning can be based on electrical conductivity. still to explain the strength of bases. Sodium hydroxide solution has many hydroxide ions than ammonia, and because of that, its conductivity is higher. So strong bases have higher electrical conductivity. And that is because of many ions, many mobile ions. They dissociate completely or ionize completely to give sodium ions, for example, and hydroxyl ion, and that will enable conductivity. Weak bases have lower electrical conductivity. And reason being that they have few mobile ions, few hydroxyl ions, just like we have said, and that is what is responsible for their low conductivity compared to strong bases. That is all about the strength of bases.